Exercise 13.4. Let's continue with the question number 7 here. We are given that a coin is biased such that head is 3 times as likely to occur as tail. What's the meaning of this? So in a coin, probability of getting head is 3 times as likely to occur as a tail. 3 times chances of occurring tail means what? It is like this. What's the probability of getting tail here? 1 by 4. Then this is 3 times, so this has to be 3 by 4. 75%, this is 25% in that sense. Usually when you toss a coin, then this is 1 by 2, this is 1 by 2, but here it's not the case. Remember, coin is designed in such a way that probability of getting head is 3 by 4, 75%, and this is just 1 by 4, that is 25%. We are given this. Okay, the coin is designed in this way. Now what do you want? Find the probability distribution of number of tails. Okay, now here coin is tossed twice. Coin is tossed twice. Okay, so here x equals to, we are given number of tails. Fine. So either you have no tails, that is 0, or you may have one tail, that is ht and th, and both are tails, that is 2t. So these are the values of x. Okay, now when x equals to small x equals to 0, so we want the probability when the random variable is 0. Random variable is 0 means what? Number of tails equals to 0. Number of tails equals to 0 means what? Your both are heads, remember, that is no tail means both are heads, HH. Fine. Now what's the probability of getting a single head, which is 3 by 4, and in second trial again 3 by 4. So what we'll get here? 9 by 16. Clear? Here events are not equally likely. Next, random variable x equals to here 1. So probability when x is 1. X is 1 means number of tails equals to 1. So either you have this or you have these outcomes, or this one, th. Let me write this, HTTH. So in this case, what we'll get here, let's write that. So we have here, what's the probability of getting head and tail? That is, for head 3 by 4, for tail 1 by 4. Plus, we used to do such things earlier. Here 1 by 4, for this one 3 by 4. So how much we'll get? This is 3 by 16, 3 by 16. So 6 by 16, which is 3 by 8. So here probability is 9 by 16, here 3 by 8. And one more, that is x equals to 2. That means number of tails equals to 2. So probability that the both are tails. And what is this probability? For single tail it is 1 by 4 into 1 by 4. So what will get? 1 by 16. So therefore I'll write finally, let me write here, therefore required probability distribution of x here, that is x equals to xi, which is 0, 1 and 2. And probability of random variable x equals to xi, that is 0, then 9 by 16 here. This is 3 by 8 and this is 1 by 16. That's required probability distribution. You can just verify that each of these should be greater than 0, and when you add all these probabilities, that it should be exactly 1. When you add this plus this plus this, it has to be exactly 1. That much you can verify. 8th question. You are given a probability distribution of a random variable x, where x, you can say it's vary from 0 to 7, and you are given the probabilities. The first question is find k. What's the value of k? That's the question. Now we know once it is a probability distribution that the sum of all the probabilities of random variable should be exactly 1. And we also know that the probability of each random variable should be greater than 0. So we'll use this. Let's add all these probabilities. So if you add probabilities here, 0 plus k, then 2k, then again 2k, then 3k, then k squared, then 2k squared, then 7k squared, plus k equals to 1. We are using this from the definition. This is the definition of the probabilities. So k will occur how many times? 3 plus 2 5 plus 2 7 plus 1 8 plus 1 9. So 9k. Plus what about k squared? 7 plus 3, that is 10k squared, minus 1 equals to 0. So this is a quadratic equation. So just we need to verify here. 10 squared plus 9k minus 1 equals to 0. Now we'll factorize. So what are the factors here? Minus 10 plus 9. So 10k squared. Here we'll write, we want plus 9 here. So I'll write here plus 10k minus k minus 1 equals to 0. Taking 10k common from this, we are just factorizing. This is not a big task for you. Just solve this quadratic equation. So one factor is 10k minus 1, the other factor is k plus 1 equals to 0. So it implies either k is 1 by 10 or k is minus 1. Right? But we know this minus 1 is not possible because otherwise probability is negative. Right? Just look at the table, you will realize if k is minus 1, then the probability is negative, which is not possible. So this is the required value. Required value. This is answer to the first question. Okay. What about the second question? Second sub question. You are asked for probability of random variable x where value of x is less than 3. So what you need to find? This means you see table, random variable starts with 0. So either x is 0 or means plus, x is 1 or x is 2 and less than 3. So you opt to 2. Now if x is 0, have a look at the table. What's the corresponding probability? 0. If x is 1, this is k. If x is 2, what's the probability? 2k. So we'll get from this 3k. But what was k? That is 1 by 10. So you have the 3 by 10. That's the value. Right. Now for the second, next sub question, for the third sub question, again that's very simple. Probability of random variable x which is more than 6. So more than 6 means only 7. What is the probability? You look at the table, it is 7k square plus k. What's the probability of random variable when this? It is 7k square plus 7. Now put the value of k. What is k? That is 1 by 10 the whole square plus 1 upon 10. So we'll get the 7 upon 100 plus 1 by 10. So from this here you will get the 17 by 100. That's required probability, multiply and dividing by 10. Okay. And the fourth sub question there, you want probability of random variable x which is more than 0 and less than 3. So what will get? P of 1 plus P of 2. You just again look at the table. Random variable is from where? It is 0 to 7. More than 0. So 1 and then 2. Less than 3. So 3 is not included. What is P of 1 probability? Your k. What's the probability of this one? 2k. So we'll get the 3k. And k is 1 by 10. So 3 by 10. That's a required probability in this case. Okay. Let's go to next question. It's the same question. Question number 9. It's just copy of this. See, there you are given this information where random variable x has this value 0, 1, 2, and otherwise for any other random variable. What's the probability of random variable x here? This is k. When it is 1, it is 2k. When it is 2, it is 3k. Otherwise, it is 0. If you have any other random variable, then the probability is 0. So this is not important. Now, what is the first question? Get the k. So you know that the summation of all this probability has to be what? 1. Sigma probability of each random variable has to be 1. We know this. And probability of each random variable should be greater than 0. It should be positive. So if you add this, you will get the 5k equals to 1. K plus 2k plus 3k. And therefore, what we'll get from this? We'll get the this is 6k, 5k plus 1, so 6k, and therefore k equals to, will get the 1 by 6. Fine, we know it like previous question. Now what is the first sub question there? The first sub question after this, that's the second one. Find the probability of random variable x which is less than 2. So p of 0, random variable start with 0, then p of 1, only 2, less than 2. What is p of 0? K. What is p of 1? You are given 2k, so you have 3k. But what is k? You know it is nothing but the 1 by 6. So 3 into 1 by 6, so 1 by 2. Same way you can answer the other sub questions. Now we'll go to question number 10, 10th question. Let's go to 10th question. That's also a nice question. Find the mean. Mean means, you know, mathematical expectation. To find mean means e of x. We know where x is a random variable. You know definition of e of x. You need the probability distribution. Of what? Find the mean number of heads in 3 tosses of a fair coin. So coin is tossed how many times? Thrice. So 8 outcomes. Coin is tossed 3 times. So therefore number of outcomes equals to, we know 2 raised to 3, which is 8. We have 8 outcomes. And what is the probability of each outcome? That also we know 1 upon 8. Okay, this is a sample space, right? We know it. These are the 8 outcomes. We have mentioned it earlier number of times. Here you have T, TH, then H, TT, then THT, and all are tails. Okay. Now, what is here? You want the mean number of heads. Okay, so what is x here? And x you are given. What is x? That is number of heads. Fine. So therefore, what are the possible values of x? You know, either you have no heads, that is all are tails, or 1 head here, 1 and 2. Maximum we have 2, and here maximum is 3. These are the possible values of x. 0, 1, 2. No heads, 1 head, 2 heads, and 3 heads. You can see. Okay. So now you can write the tabular form, or you can do directly also. So let me write that tabular form. Your outcomes you can do directly also, not a big task. Then this is let me write random variable x here, and this is probability distribution of x. I've skipped one column here, that is probability of each outcome, which is 1 upon 8, you know, total 8 outcomes. Random variable 0, that is number of heads equals to 0, that is all are tails. What is probability of this? 1 upon 8. Fine. Then next, go to next random variable, which is next random variable 1. That is number of heads equals to 1. 1, 2, 3. There are 3 outcomes. TTH, THT, and you know HTT. probability of each of these is 1 by 8. So here 3 by 8. We did such things earlier, you know it. Okay. Then go to random variable 2. So number of heads should be 2. 1, 2 and 3. So we have HHT, then HTH and THH. So again 3 by 8. And then finally all our heads. So we have here 3 and this is 1 upon 8. Okay, so this is a probability distribution. Now you can find mean value very easily. What is the definition of mean value? Once you get the probability distribution, it is just this into this plus this into this plus this into this plus this into this. Alright, the mean of random variable x equals to, therefore mean of x equals to E of x. That's called mathematical expectation, which is sigma I runs from 1 to n xi into p of xi. So this is equals to, just I'm writing from the table, 0 into 1 upon 8 plus 1 into 3 by 8 plus you have 2 into 3 by 8 plus 3 into 1 upon 8. This is 0. Here you have 3 by 8. This is 6 by 8 and this is 3 by 8. So we'll get the finally 12 upon 8. That's required, mean value, which you can just write, 3 by 2, which is just 1.5. Required mean of the random variable x of number of heads. Okay, fine. The 11th question, you are given that 2 dice are rolled. 2 dice are rolled. So we know we have here 36 outcomes. Sample space, it's like 1 1, then 1 2, up to 1 6. It is 2 1 up to 2 6. And so on. Finally it is 6 1 up to 6 6. So we have total 36 outcomes. Probability of each outcome, we know 1 by 36. That we know. Let me write here. And probability of each outcome equals to 1 upon 36. Okay. Now, what you want? X denote the number of sixes. And here x is number of 6 is 0. So what are the possible values of x in each outcome? So there is no 6 here, 0. Here you have 1 6 and here you have 2 6s. So these are the possible values of random variable x. 0, 1 and 2. Right? 0 means 6 does not appear on any dice. 1 means 6 appears exactly on one die, and this double 6. So you need to count all these outcomes. That how many outcomes are there? There is no 6 that you need to count. How many outcomes? There you have exactly 1 6. And how many outcomes? There you have exactly 2 6s. That is just 1. So now we go for probability distribution, because to find mean we need probability distribution. So I'll write in the tabular form, here outcomes, small u. Then you have probability of each outcome, it, 1 by 36. You can drop this column if you want. Then random variable x and then probability of x. Fine. So your answer to this probability of each outcome, we know it is 1 by 36. So here just 1 by 36. That we know very well, as I stated in the beginning. Now random variable is 0. What is the meaning of random variable is 0? That means outcomes are free from 6. That means 6 does not appear on any of die. Okay, so if you list out here, it's like this: 1 1, then 1 2, then 1 5. So 5 outcomes, Similarly for 2, 2 1 up to 2 5, and the same thing is for 5 1 up to 5 5. So how many such outcomes? 5, 10 and so on. So it will be 25. So what's the probability of this one? 25 by 36. For 1 it is 1 by 36, and these are 25. Okay, next, random variable 1 here. Random variable 1 means what? 6 appears exactly on one die. Okay, so you know this. If you just look at there, you can list out this. You have left with 1 6, then here 2 6, then 3 6, then 4 6, then 5 6. Okay, then the last one, that is 6 1, 6 2, 6 3, 6 4 and 6 5. Okay, so how many such outcomes? You know, 10. So this is 10 by 36. And now at the end, you know here probability for a random variable 2 now. 2 means exactly 2 6. So we have such outcome only 1, 6 6. Number of 6 is equals to 2. Probability is here 1 by 36. So this gives us, the last two columns gives us the probability distribution, we know, these two columns. And therefore mean of x, that is E of x, which is equals to, you know definition, this into this plus this into this plus this into this. I runs from 1 to n, xi into p of xi. So 0 into this, 25 by 36 plus 1 into 10 by 36 plus, you know, 2 into 1 by 36. So what will get here? 10 plus 2, 12 by 36. We'll get finally 12 by 36, which is just 1 by 3. That's mean of random variable x, expected value of random variable x here. Question number 12. I'll not do it. Try it. It is for you, right? It's a good question. You must try. Like earlier 2 questions only. I'll go for directly question number 13. Let x denote sum of numbers obtained when 2 dice are rolled. Okay, so 2 dice are rolled. So you know 36 outcomes. Fine, n equals to 36. What is sample space? As I have discussed in the previous example, xy, where you know x varies from 1 to up to 6, y also varies from 1 to up to 6. So n equals to 36, and you know probability of each outcome equals to 1 by 36. 1 by 36. Okay. Find variance and standard deviation. So you need first probability distribution, right? So we find probability distribution. So what is definition of random variable x? You're already given. Definition of x, that's given in the question. What's the definition? Sum of numbers on 2 dice. Sum of numbers on 2 dice. Numbers on the dice. Okay. So you know lowest sum, if you take 1 1, that is 2. Then you can have 1 2 also, so 3. Then 4, you may have 2 2. Then 5, then 6, then 7, 8, 9, you may have 5 5, so 10. Then you may have 5 6, which is 11, and the largest sum, you know, 6 6, which is 12. Fine. These are the values of random variable x. Now we prepare that table. So I'll write here outcomes. Let me write here outcomes. Then I'll write here random variable x and its probability. It's probability of random variable x. You can drop that column, that is the probability of each outcome is 1 upon 36. That I have dropped here. Fine. Okay, so now here we start with 2. So list all outcomes where you know summation is 2. So there is only one outcome, you know 1 1. 1 plus 1 2. What's the probability here? 1 by 36, because probability of each outcome you know it is 1 by 36. Fine. Go to random variable 3. So you know here 1 2 and 2 1. These are the outcomes. So what will get here? 2 by 36. Then go to 4. Next random variable. What are the outcomes? You know 1 3, then 2 2 and 3 1. Right? We are just listing from these only, remember. So 3 by 36. Go to 5, random variable 5. So just think how many outcomes you will have where the summation is what? 5. Summation should be 5. So start sequentially. You can have 1 3. Don't take randomly. Then go to the second row. Second row. Okay, this is 4, sorry. I need to write 1 4. So 5. Then go to second row, that is 2 3. Then go to third row, that is 3 2. And then second row there sorry, I need 5, so 1. Then next row 4 1. So how many outcomes you have total here where the summation is 5? 1 2 3 4. So for 5 it is 4 by 36. Fine. Now we go to 6. Okay, so for 6 here you know summation should be 6, that is like 1 5, then 2 4, then 3 3, then go to next row which is here 4 2. Fine. And one more row which is 5 1. So how many outcomes? 5 outcomes. So 5 by 36. Same way list out for 7. I'll not list here. I'm here writing directly. If you list out for 7, it will be 6. So 6 by 36. Then for 8, list out for 8. Right? This is for you. List all. You will get, if you list for 8, you will get the 5. So 5 by 36. Go to next 9. In 9, if you list out, so there you can check, you will get the 4. So I'm writing 4 by 36. Then go to 10. So in 10 again you can list out here. I leave it for you. So for 10 you can just verify you have just 3. So 3 by 36. For 11 obviously 2. 5 6 and 6 2. So 2 by 36. And for 12 obviously there is only 1. That is 6 6. Here you have 5 6 6 5. Fine. This 4 I leave it for you. And this would be how much? You know 1 by 36. I hope this is very clear to you now. Okay. So I've left this much for you. Finish this. I already given final number. So it's not big task. So this is probability distribution. Now you are asked for what you are asked. First you are asked for mean, and then you are asked for variance. Not variance, what is that? Sorry. Variance and standard deviation you are asked. So you need mean first. You know it, to get the variance and standard deviation. So first we find the mean. Mean means E of x. What is the definition of E of x? Sigma I runs from 1 to n xi into p of xi. Right? Now this is not a big task for you. So what you need to do? This into this, plus this into this, plus this into this, plus this into this. I'm doing that. So 2 into 1 by 36 plus 3 into 2 by 36. 3 into how much? 3 into 2 by 36 plus 4 into 3 by 36 plus 5 into, this is one term, this is second term, this is third term, 5 into how much? 5 into 4 by 36 plus 6 into how much? 5 by 36. 6 into 5 by 36. 7 into plus 7 into 6 by 36 plus 8 into 5 by 36. Now it is in the decreasing order. Plus here 9 into 4 by 36 plus 10 into 3 by 36 plus 11 into 2 by 36 plus 12 into 1 by 36. Right? Keep 36 as the LCM so you can simplify very easily. 36 is the LCM. And numerator would be here 2 plus 6 and so on, simplify. Finally you will get just 12 here. If you add all this, you will get the 252 by 36. That is nothing but the 126 by 18. And further, if you just write, it will be 18 sevens. So EX will be 7 here. Mathematical expectation is just 7. Now our question is to find what standard deviation and variance. So we need E of x squared. Now we just find E of x squared. What is definition of this? Sigma, if you remember, I runs from 1 to n, xi squared into p of xi. If you just recall the theory. Square of variable into probability. So we are squaring here. Square of variable 4 into probability 1 by 36 plus square of this, which is 9 into 2 by 36 plus what we'll get here, 16 into its probability. 16 into what's probability? 3 by 36. Square of this, that's 25 into 4 by 36 plus you have 36 into 5 by 36 plus you have 49 into 36 by 36, which is, that is 6 by 36, I'm sorry, 49. Then come to this 64 into 5 by 36. Probability as it is, just to square the variable. 81 into 4 by 36 plus 100 into 3 by 36 plus here next 11, that is 121 into its probability, that is 2 by 36, and finally the last one, that is 144 into 1 by 36. So we just need to simplify. Keep 36 again as LCM, and here you need to simplify the numerator expression. So here if you just multiply and add, you will get 1974, and that is just 54.83. that is E of x squared. 54.83. Now what we need? We need variance. So here variance, which is V of x, if you remember, it is E of x squared minus E of x the whole square. That's a definition we already stated in the theory portion. So that's why we have computed this Ex squared. Now what is E of x squared? Which is 54.83 minus, what was this? That was 7, so 49. So we'll get here 5.83. that is variance. And you know from statistic and standard deviation, that's a square root of variance. So square root of 5.83, which is roughly 2.41. Fine. The next question, question number 14. There you are given 15 students with this much ages here. One student is selected at random. So what's the probability of getting one student? 1 by 15. There are 15 students here. And probability of each student equals to 1 by 15 because one student is selected. And what's the definition of random variable x? That is nothing but what? You just read the question. That is age of the student. Age of the student. So what are the possible values of the x? Note down different ages. So it starts from 14, then you have 15, then 16, then 17, then 18, then 19, 20, and the highest is, have a look, 21. Right? Highest age is 21. Okay. Now, how many times 14 occurs? Just read it occurs twice. So I'm just writing directly. What's the probability of this? 2, and probability of each outcome is 1 by 15. So 2 by 15. This occurs just 1. So here 1 by 15. 16 occurs twice. So 2 by 15. I'm writing probability. Now I hope you are clear with the previous question also. So this you can write very easily. 17 occurs just 3 times. Count. So 3 by 15. 18 occurs how many times? Have a look, 1 time. So 1 by 15. 19 occurs twice. So this is 2 by 15 because probability of each outcome is 1 by 15. 20 occurs how many times? Just have a look at data. I suppose 20 occurs 3 times. So this is 3 by 15. 3 into 1 by 15. It's like this. 21 is just 1 time. So 1 by 15. So indirectly I have now probability distribution of random variable x. Okay. And what is asked? You are asked 3 things. The one is E of x. E of x, you know very well, mean sigma xi into p of xi. I'm sure now you can do this. We did it. This into this plus this into this plus this into this and so on. That's mean. Then you are asked for variance. So for that you required E of x squared as we did in the previous question. Sigma square of random variable into its probability, remember. So 14 square into this, 15 square into this, 16 square into this, that gives you this. This is mean. And finally, what we'll get from this? Variance. What is variance? You can see her top line, that is variance E of x squared, this obtained value, minus E of x the whole squared, that is variance. And next, what you need? You need standard deviation. So you know standard deviation is just the square root of variance. So I'll write here, once you get this, therefore SD equals to here square root of variance, and therefore you will get this. Okay, so with this I'm sure you can complete it now. So we go to next question, question number 15. Let's see what it says. Question number 15 here. So here 70% of the members favor and 30% oppose a certain proposal. Okay. A member is selected at random. We are given x here. What is x? 0 if he is opposed. Okay. So you have the probability for this, and x is 1 if he is in favor. Okay, that's given. So x has 2 values, 0 and 1. What's the probability of x? If he opposed, then the probability is how much? Just read the question. Probability opposed, then 30%. Okay, so this is 30 by 100, and in the favor the probability is 70%, so 70 by 100. So this is indirectly what? The probability distribution of random variable x. Fine? Is a probability distribution. You can see that the summation is exactly 1. There is a probability distribution of x. Now what is asked? E of x. Okay, so now it's very simple for you. So therefore E of x, which is mean, which is given by sigma I runs from 1 to n xi into p of xi. So this into this plus this into 100, 30 by 100 plus 1 into 70 by 100. So you have here 0.7. Therefore E of x equals to 0.7 mathematical expedition. What else you are asked? Variance. But before you do the variance, we need to find what? E of x squared. What is definition of E of x squared? 2 times already mentioned. Sigma xi square into p of xi. Square this into this, which is 0. Square this, which is 1 square, into its probability, which is this much. So again you will get the same, which is 0.7. E of x square is this. And therefore finally we'll get the variance. So therefore I'll write here variance equals to, variance equals to, now E of x squared minus E of x the whole square. Fine. What is this? This is 0.7 and this is again 0.7 but whole squared. So we'll get the 0.7 minus 0.49. So here 50 and therefore 0.21. That's variance. We'll go to next. It's an MCQ. It's a really nice question. See what is given. The mean of numbers obtained on throwing a die. Okay, so you have 6 outcomes. Having written 1 on 3 faces. Okay, so die is tossed here. So probability of each outcome, probability of an outcome is equals to 1 by 6. Okay, now here sample space is this. What is the sample space? So 1 on 3 faces. So 1, 1 and 1. 2 on 2 faces. So 2, 2. And 5 on 1 face. Okay. Now you want the mean of numbers obtained on throwing a die. Okay. So what is x here? That is number obtained on the dice. That is 1, 2 and 5. What is the probability of random variable x? Now you can write very easily. 1 occurs how many times? 3 times. Probability of each outcome is 1 by 6. So 1 by 6, 1 by 6, 1 by 6. So here 3 by 6. Probability of 2, this occurs twice. So 2 by 6. Probability of 5, that is nothing but 1 by 6 here. So this is indirectly probability distribution. You want mean. Mean means E of x. What is E of x? This into this, 3 by 6. This into this, which is 4 by 6. And this into this, which is 5 by 6. And therefore, what we'll get from this? This will be, 12 by 6. So it is just 2. So E of x is 2. And therefore B is the correct choice. The important one is this probability distribution. This is probability distribution. Right. The important portion is this. These are the values of random variable x and this is its corresponding probability. Right? You now clear with that, I think. So next 17th, which is also an MCQ. 2 cards are drawn from a pack of 52 cards. 2 cards are selected. Okay. Let x denote the number of aces. Okay. So here x is number of aces. Okay. So you are selecting 2. So either both the cards have aces 2. Or one card have aces which is 1 and no card have aces which is 0. 0 means no card would have aces. 1 means 1 card would have aces, and 2 means 2 cards have aces. Okay. So these are the possible values of x. Now we want the probability for x equals to 0, because we need the probability distribution. Why we need the probability distribution? Because we are asked for E of x. So probability of x when x is 0. Okay, what's the meaning of this? That means probability that you have known as cards, right? Card does not have aces, remember. How many such cards? 48. You are selecting 2, right? Other than aces there are 48. So 48 C2. Total cards 52. From 52 cards, let me write here. Total cards you have 52. So 52 C2, right? You need to simplify this. Okay. Let me keep right now as it is, or you can just simplify. How do we simplify this? 48 into 47, 46 factorial will cancel by 2. 2 factorial. What about this? 52, 51, 50 factorial, that will get cancelled with this upon 2. Right? You just simplify this. So you will get the 1128 upon 1326. Fine? Okay, that's 1. Now probability for this. Probability of x when x is 1. Okay, what's the meaning of this? That means 1 comes from S's. Okay, so 1 is an S card and 1 is non-S card, remember. Okay, now how many S's are there? 4. There are 4 S's, So 4C1, remaining 48. So 48 should be 1 should be selected from their 48, and total number of cards is 52. So 52C2. Fine. Now we just need to simplify this. What is 4C1? It is 4. 48C1, it's always 48. What about this? 52 into 51. 50 factorial will get cancelled with this, and this will be into 2. So what will get from this? Just multiply and simplify. You will get 192 upon 1326. Okay, I'm keeping same denominator. And finally, for x equals to 2, here random variable is 2. What's the meaning of this? That means 2 are S's cards. 2 are S's cards. Both are S's, remember here. There are 4 S's, so here 4C2. 2 selected out of 4. And total 52, so 50C2. What is 4C2? 4 into 3. 2 factorial will get cancelled upon 2. The whole upon. Here 52 into 51. 50 factorial will get cancelled upon 2. So again this 2 will get cancelled. And here if you just simplify, you'll get the 6 upon 1326. So these are the probabilities of these 3 random variables. And now just if I write 0 then this probability, 1 then this probability, and 2 then this probability. Okay, so now I'll write just mean here. Okay, directly I'll not show that. So therefore E of x, that is mean value, which is sigma I runs from 1 to n xi into p of xi. So 0 into 1128 upon 1326 plus 1 into 192 upon 1326 plus here 2 into 6 upon 1326. So this is equals to here finally. If you just simplify and add them, it will be 204 upon 1326. And that if you simplify, you will get just 2 upon 13. And that is nothing but the option D here.